All right, so sorry about that brief interruption there. I had somebody coming in the middle of recording here. All right, so we left off, we were talking about the fact that that very first reaction that you have to do for the Unit 4 lab does form a precipitate. All right, so we talked about the ions that are in the two chemicals that we reacted together, talked about the charge on those ions, and now we just got into talking about double displacement reactions. Okay, so what's going on here? We have just a generic compound AB with ions A and B, generic compound CD, and in a double displacement reaction or a double replacement reaction, depending on which book you're reading from, that sort of thing, the two cations, the positive charged parts, switch spots. All right, so now C is attached to B, CB, and A is attached to D, making AD. Now, when we do that, all right, for our reaction, we have BaNO32 plus Na2SO4. Your sodium and barium are going to switch spots. All right, so we'll have sodium and nitrate. And right now I'm not going to add any numbers to anything because we need to rethink these numbers because the charges matter. And we're going to have barium and sulfate. All right, so I haven't added any numbers. So what I need to do now is determine if numbers are needed. So we know sodium is +1, nitrate is -1. All right, so I don't need any little numbers here. These cancel out. The charges cancel with 1 sodium and 1 nitrate. All right, then barium is +2, and sulfate is 2-, so same thing. These cancel out. I don't need any extra numbers. However, I do need to balance my reaction. All right, on this side, I have 2 nitrates, and I have 2 sodiums, but right now I only have 1 of each. So you just need to put a 2 in front there. Now, when it comes to the questions, so this one, we're on that question 2 list. List at least 2 chemical reactions that result in a white precipitate for these reactions. List the possible chemical name of the precipitate. What do these reactions and other ones of the white precipitate have in common? All right, so technically speaking, I'm not holding you to knowing the solubility rules, and I'm perfectly acceptable with you saying that either one of these could be the precipitate. Let me actually show that again. So either of these products could be it. There is for sure only one of them that is, and that's what I want you to try to maybe use question 3 to answer. Okay, so looking at question 3, of all the reactions you performed, how many resulted in a precipitate and how many did not? Make a general statement about the interaction of aqueous compounds using the term double displacement reaction. Okay, another way I want you to kind of think about this question is see if you can find any sort of pattern as far as like which compounds actually form precipitates, right? So you might end up seeing some patterns here, right? So if, say for example, in all of the white compounds, you have a precipitate that has nitrate in there, right? Maybe it's the nitrate that's forming that white precipitate. That's not going to happen, all right? Because in this one, it's actually the barium sulfate that's creating your precipitate. Sorry about that. Okay, but for question 3, I want you to think of this as being a question more like, what are some rules for when a precipitate will form? Okay, thinking about it this way. You're looking for rules that you could use to predict the formation of a precipitate without actually running the reaction. If you sit there and do a really careful job of marking down which ones form a precipitate, figuring out what compounds they make, you should find some patterns as far as what the compounds look like when a precipitate forms, okay? There's also sometimes you might run into something like, for example, this reaction would work the exact same way if we did barium chloride and sodium sulfate. And what you'd end up making is 2 sodium chlorides and then BaSO4. The exact same thing would happen. This compound here, I know you don't necessarily know the solubility rules, so you don't know right off the top of your head that nitrates never form precipitates. But if you end up with sodium chloride and something else, right, the fact that you see sodium chloride, you know that dissolves in water. All right? If you know that the compound dissolves in water, then the other one has to be the precipitate. Because a precipitate is something that doesn't dissolve in water. It stays in solid form. You can still see it in the water. Okay? So, hoping this is going to help jog some ways to kind of approach question 3, some patterns to try to look for. See if you can come up with a rule or two, like if I have this certain compound, it will always form a precipitate if it's paired up with this certain kind of compound, that sort of thing. But again, if you get there, you get stuck. This whole idea of being able to predict these compounds, get their numbers right, and things like that, that is essential to the rest of this block. So if this isn't making sense, you need to come get help. So good luck with the lab, and don't hesitate to ask for help if you need it.